For your homework last night, you should have been able to, have a grasp on Algebra 1. You learned it. Algebra or Geometry, you applied it a bunch. And then Algebra 2, we're just going to do it at a little bit more of an intense level. One of my big goals today is to, I know you know how to do a lot of these problems, but also talk about the difference between evaluating and simplifying, okay? Evaluating has the word value right in it, yes? So when you're evaluating something, you're looking for that final numerical number value. That's the answer. Versus simplifying is usually an expression that is going to simplify and will have numbers and variables in the final answer. Okay? So when you are asked to evaluate, you are given numbers, a number or numbers to plug in for the variables, and then do the order of operations and come up with that single value answer. So here we're going to plug in -3, and anytime you plug in numbers, sometimes it's more important than others, you plug it in with parentheses around it. So -3 squared minus 4 times, and then I get a -3 in there for my x, minus, and a -5 in there for my y. Notice wherever there was an x or a y has an additional now set of parentheses in there. Now, I'll be honest with you. The parentheses in here don't really do as much. You'd have the same answer with or without them. This set of parentheses is going to make a big difference because, and we'll talk about this is going to come up over and over again. It's one of the most common mistakes. You've probably made it 1,000 times already, and I hope that you only make it 100 times this year. Okay? -3 in parentheses squared versus -3 without parentheses squared. Okay? This one means, squaring in general means multiply the base by itself. The base of this squared is the entire set of parentheses. The parentheses are being squared. So the -3 is getting multiplied by itself, and that is 9. Over here, I don't want you moving ahead on the problem, I want you paying attention to what I'm saying. Over here, the base of the squared is just the 3. So the negative is sort of just out in front, and then what's being squared is 3, and so we would write 3 times 3. So it's the negative of 3 times 3. So it's -9. And your calculator is going to mirror this same thing. If I type in with parentheses -3 squared, I'm going to get 9. If I type in -3 squared without parentheses, I am going to get -9. And people don't, when the base is a negative number, they don't have it in parentheses. They oftentimes get the wrong number and get it wrong. Okay, and maybe that even happened on your homework last night, and then you had realized, oh, my answer's not right. Let me go back and see what's wrong, and maybe you found it. But be careful of that. Okay, like I said, these parentheses aren't going to do much, but this is going to be 9. Here I'm going to simplify within the larger set of parentheses. So -3 minus -9 turns into -3, or minus -5. -3 plus 5 is what that turns into, because the double negative. And -3 plus 5 is 2. Then PEMDAS. We've done exponents. We've done parentheses. We've done exponents. We do multiplication. 9 minus 4 times 2. 4 times 2 is 8, so 9 minus 8, and we get 1. We have evaluated. We found the final value. Okie doke. We'll come back to number 2. I want to jump down to simplifying. So notice in the simplifying section, there is no value given to plug in. Okay, so we're not going to evaluate, we're just going to simplify. Now, simplify typically means 2 things. Step 1, distribute. And step 2, combine like terms. A process you should be very familiar with. Okay. So in number 1, is there any distributing that you think can be done, Aiden? Where's Aiden? Aiden, any distributing? What's not in parentheses? Absolutely not. You can. You must. You must. Good job. You have to. You always, when there's multiple set of parentheses, work inside out. So kind of just focus inside that larger bracket. There is distributing to do. 8 minus. You want to subtract both of those terms. So keep your bracket. That's going to be 8 minus 2y. And then what happens with minus negative 4, Cameron? Becomes plus 4. Very good. Okay, so we did distribute there, and the 6 minus 5 on the outside remains the same. What would you do next, Nathan? Or who's Nathan? Okay, Nathan, what would you do next? Very good. Distributing the negative 5. Now, there are a lot of people that would make 6 minus 5 1. You never do subtraction this early, right? Ever. You're multiplying. Your distributing is multiplying. So yes, it's 6 minus 5 times. So you're going to distribute this negative 5. For the record, you could have combined like terms within that first. If you chose to add the 8 plus 4 and get that cleaned up first, you could have. I'm going to save it all to the end. So negative 5 times 8 is negative 40. Negative 5 times negative 2y is plus 10y, and negative 5 times 4 is negative 20. So I've distributed. I actually had to do it twice because there were 2 levels of it. And Kirsten, what would you do next? And what is that? 6 minus 40 is negative 34. Negative 34 minus 20 is negative 54. Good. So negative 54 plus 10y. So she was on to the combine. And this is probably not the best way to leave your answer. If it was open response, it would be accepted, unless it said something like in, I guess, appropriate polynomial form. You know how like the y squared term comes first, followed by the y term, followed by the constant. So right now our constant should really be at the end. So your 10y would be first, and then minus 54. That's really the clearest polynomial form. Okay, that's the best written way of doing that. Okay, so we simplify over here. Any distributing to be done, Madeline? Where's Madeline? Madeline K. What are you going to distribute that to? Very good. So when you multiply 3 things, now you can choose to distribute that first, just to the first 2 terms, or you could choose to distribute these first, but she said this, so I'm going to just distribute my 5x cubed. I'm going to multiply essentially the first term with the second term. So that's going to make what? What's 5x cubed times 2x, Isaiah? Someone help him out. 10x to the 4th. 5x cubed times 2x is 10x to the 4th, right? X to the 3rd times another x makes it x to the 4th. 5x cubed times 1 is plus 5x cubed. Now that needs a set of parentheses around it. And then we have the 3x squared minus 7. Okay? We will distribute from here now. This is foiling, yes? Okay? So we're going to go through 10x to the 4th times 3x squared. The 10 times 3 gives us 30. The x to the 4th times the x squared gives us x to the 6th. Very good. 10x to the 4th times negative 7 gives us negative 70, and x to the 4th stays x to the 4th. So our 10x to the fourth has been distributed through. Our 5x cubed now needs to be distributed through. 5x cubed times 3x squared. 5 times 3 is 15. X to the third times x to the second is, we add those exponents. X to the fifth, very good. And last, 5x cubed times negative 7 is negative 35x cubed. How do we feel about our polynomial form? Is it good? Needs to be rewritten. Yeah, how so? Very good. Those exponential terms need to be written in descending order. Again, kind of it depends on how they phrase the question if they would take off points for not doing that. But if you want to play it safe, you should always try to get those exponents in descending form. Number 3, this is huge. This is not as quick as you all probably want it to be. Yes? Okay? Because I don't distribute an exponent to a polynomial. There are 2 terms there. I don't square this one and square this one and call it a day. What I'm squaring is whatever the entire set of parentheses. Squaring means multiply it by itself. So I have to multiply 5x minus 3 times 5x minus 3 times itself. Okay? So 5x times 5x, 25x squared. 5x times negative 3, negative 15x. I've distributed my 5x. Now I have to distribute my negative 3. Negative 3 times 5x is minus 15x. Negative 3 times negative 3 plus 9. And we combine like terms. Negative 15 with a negative 15 makes negative 30. In this type of problem, when you're squaring a binomial like this, binomial 2 terms, it's always going to be 2 of the same thing in the middle, so it's just going to kind of be double that, right? Okay. If we just squared both pieces, 5x squared would be 25x squared, negative 3 squared would be positive 9, we would have missed the middle term. Because in the FOILing process, you miss the outer and you miss the inner, which combine to kind of make that double the 15 number of 30. You follow? I want you to get to a point where you can do this without having to expand it. So yes, 5x squared becomes 25x squared the first term, negative 3 squared is the positive 9 the last term. To get the middle term, you just multiply these 2 together. Kind of think about your outer and inner would be 5x times negative 3. That's negative 15x, and that middle term is always going to be double that. You follow? Okay, so if I was doing it quickly, let's go to this one on the back. We'll talk about the identity part in a minute. But if we're going to square that without expanding it and taking that time to write all that, we're going to square the 3x, that's 9x squared. We're going to square the negative 4, that's plus 16, but I'm leaving a little gap in the middle for that middle term. My outer times my inner is going to be 3x times negative 4, which is what? Negative 12x, but I'm going to have 2 of those, right? It's going to be negative 12x and negative 12x, which is going to make negative 24x. So I do want you, I would prefer if you get to a point where you can do that without expanding. Just imagining that FOILing process happening. But if you're not there yet, that's okay. To play it safe, if you always want to expand it, you may. Okay? Let me just kind of clarify one thing here. If it's not a binomial, and we'll get to this more when we work on exponents, if it is just a monomial, if it's just one term, if it's not 5x minus something or 5x plus something, maybe it's just 5x squared y. Maybe that's the term. That's a monomial. That's a single term. It's a long single term. but two terms when it's separated by a plus or minus. If I ever square a monomial, I can sort of distribute the squared. 5 squared is 25. X squared squared we'll get to is x to the 4th, and y squared is y squared. So that with a monomial, you are kind of distributing it to each term of the monomial. But a plus or a minus sign kind of makes it a polynomial, and you have to expand and FOIL. Okie doke? All right. So on the back side, identities are something that are going to come up all year long. You're going to be seeing, prove this is an identity, okay? When that happens, you'll be given an equation. You simplify the left, kind of as a separate piece. You simplify the right as a separate piece, and you pray, keep your fingers crossed, that they're equal, okay? And if they're equal, then you've proven it. It's not a 2-column proof. You're done with those. You will not do any of those this year. It is simplify the left, simplify the right, and hope that they're equal. Okay? So I'm kind of going to go fairly quickly through this one. If you just want to watch, you can do that. But I would first work inside these brackets. I would distribute, and I would get 6x squared minus 12 plus 5. I actually kind of prefer if you just watch, to be honest. And then I would distribute my negative sign. So 18x squared plus 4 is going to make it minus 6x squared plus 12 minus 5. And I'm going to combine like terms starting with my x squared. So that's going to make 18 minus 6 is 12x squared. 4 plus 12 is 16. 16 minus 5 is 11. So this side becomes that. Then you bring down your equal sign. And we're going to hope that this side also becomes that. We will see. 6x squared plus, I'm distributing, 15x. That takes care of this first part. Here I can distribute my negative 5, so minus 15x plus 5. I'm multiplying. And then I'm going to distribute my 6 on the third piece. Plus 6x squared plus 6. Now I'm going to combine like terms. I've got 6x squared plus another 6x squared is 12x squared. Done. Plus 15x minus 15x cancels. Plus 5 plus 6 plus 11. There, I've proven it. Okay? And that is an identity. You prove that it's an identity. Identity is when it equals itself. It doesn't look like it equals itself to start, does it? But once you simplify the left, simplify the right, it equals itself. You will be asked to prove identities throughout the year with every different type of equation that we look at. Okay? Here, it's kind of getting at this concept where it's asking you to find what the A value has to be, the B value has to be, and the C value has to be to complete the identity. So when I squared this out, I got that. And that equals ax squared plus bx plus c. I can't really simplify the right. So what is the a value have to be? This side is simplified. What would the a value have to be? 9. What would the b value have to be? What'd you say? Very good. Negative 24. And the c value would have to be 16. And so you found the appropriate values to complete that identity. Okay? All right, so we're going to stop there. I'm going to hand out your homework. Remember, your homework is to be done